Yeah, hello everyone. Myself Sachin Kumar. Today I'm going to discuss a very important topic. This topic is called the B tree. Basically, B tree has a lot of applications and primarily it is used for the indexing purpose. And if we talk about the properties of the B tree, so to define the B tree, basically perform we need to define the order of the tree. The order of the tree we are taking here, this is m. Based on the value of m, we can define the B tree, and this B tree is different than normal trees, just like binary search tree, AVL tree, and other trees, because binary search tree and AVL tree have exactly one key in one node, but B tree may have multiple keys in one node. So how many values, how many keys are possible in a node of the B tree? So it depends upon the order of the tree. So therefore, order of the tree is very crucial, and based on this order, we can define the entire tree. So in this video, I am going to define the m order B tree, and the value of m may be from 2 to 3, 2, 3, 4, 5, like that. And after that, we will discuss one example based on this B tree where we are taking the value of m equals to 5. So first of all, now we are going to discuss the important properties of the B tree, how we can create the B tree, and how we can perform the insert operation into the B tree, and how we can delete the items from the B tree. So these operations will be also discussed in this video in very detail. So first of all, we are defining here order of trees here m, and after setting the order of the tree, so it has other important features, other important properties, just like all leaf nodes are at the same level. So in the B tree, all the leaf nodes are at the same level, and this is the perfect height balanced tree, because in BST, any node, basically nodes are placed at the left hand side and right hand side based on the value, but leaf nodes are not at the same level in the BST. Same thing with the AVL tree also, where balancing factor lies from -1 to +1, and but in case of the B tree, balancing factor is always 0, because all the leaf nodes are defined at the same level. After that, it has another important properties here. All non-leaf nodes have at least m by 2 children. So we need to take here m by 2 children. The word is here at least, and at most is here m. So basically is here m tells to you how many children are possible. The maximum m children are possible and minimum m by 2 children are possible. So basically this m by 2 is here basically ceiling value. Sorry, floor value. This m by 2 is a basically ceiling value. We have to take here upper one. For example, this m equals to 5, then 5 by 2 equals to 2.5. So we have to take here 3. So therefore, minimum 3 children will be required for non-leaf node if value of m equals to 5. And when we talk about the root node, so root may have minimum 2 children, and maximum value depends upon the this m. And after that, another important property that we use here is based on the keys, how keys are placed. So keys are placed in the ascending order in particular node. Now, how we can define the insert operation? For that purpose, we are taking here m equals to 5, order of our tree is 5, and we have here, for examples, values like 10, 20, 30, 40, 50, like that. So we have here these values, and later values can be also added as per our own requirement to explain the example in the better way. So first value is here 10. We are putting 10 into B tree. Now next value is 20. Since 20 is greater than 10, so we have to place the elements in the ascending order. So we need to place 20 here. Now next value is 30. 30 is placed here. Next value is 40, and last one value is 50. So since now we have the total 5 values, 5 keys are here, but as per the our definition of the B tree, since our order of tree is 5, so therefore number of keys should be maximum 4, but in this case we have total 5 number of keys. The relation between number of keys and order is very simple. I mean, number of children is greater 1 than number of keys. So therefore, if order is 5, maximum children are maybe 5, and number of keys should be here 4. So therefore, we have here 5 keys and maximum 4 keys can be possible. So B people are violating the property of the B tree. So therefore, this node is split into 2 parts against the mid value. Mid is here 30. So therefore, this is split into 2 parts. So 30 will be up here, and 10, 20, 40 and 50, like this. Now the property of the B tree is satisfied here. You may see here all the leaf nodes are at the same level, and root may have minimum 2 children. So here exactly we have the 2 children, and number of number of keys are here 2, and this is here our permissible number, because for the non-leaf node, minimum number of children will be here 3. So it may have here further 3 children, like this. Some values are here, some values are here, some values are here, like this. So we can put the values accordingly here. So we have to remember the thing in such a way that here all the values should be less than 10. I mean, values should be here 5, 8, 9, like this. Here values should be in between 10 to 20, like 12, 14, and here values should be greater than 20 and less than 30. Values may be here 25, 27, 28, like this, and further here it has 3 children, like this. So if you see here, further all leaf nodes are here at the same level, and non-leaf node, non-root node has, minimum 3 children. The minimum 3 children, this is our property, and here number of keys are 2, because we have here total 3 children's. Number of keys are less than 1, then it numbers of children. So all the properties are satisfied here. So whenever we are creating the B tree, so we have to perform the insert operations, and insert operation is possible like this. And when we talk about the delete operation, how we can delete the nodes from the B tree. So for it, further, say we have here our this example, earlier example, say 30, 10, 20, 40, 50, and say we have one more key 60, like this. So we have here say a total here 2 keys are here, we have the total 3 keys, If we want to delete 60 here, then we can delete 60. No harm in it to delete the 60. Now values will be here 40 and 50. But imagine that if we are not deleting 60, I mean we are keeping here 60 as it is, and we want to delete 10. We want to delete here 10. This particular node, this particular key, we want to delete here. If you see here, after deleting 10, it has only one key. But as per our property, minimum number of keys should be 2, because order is here 5. Minimum number of children should be 3 for non-root node. So therefore, number of keys should be here 2. Here we have only one key. So if we have the case like this, then we can borrow the key from its sibling. So here this is the sibling. So 40, 50 and 60. So we can borrow 40 here. After borrowing 40, 40 will be up and 30 will be down, like this. So our structure will be like this: 20, 30, 50 and 60. So in this way, further we are seeing that we have here two keys. So this is here our permissible number. So in this way we can delete this particular key from the our B tree. This is the way to perform the delete operation. And now we are performing the insert operation and delete operation in detail. Whatever we have discussed in the previous few slides, we are going to discuss these things in detail for better understanding. Further, we are taking here order of tree is 5, and we want to perform here these number of keys, and we are assuming that A is smallest and Z is the largest. So initially we have inserted here A. Now B will insert here G. G is inserted here. F should be here and B should be here. So if we see here all the keys are in the ascending order. So in this way, this all the property of the B tree is fully satisfied. No properties violated here if we are inserting here initial 4 keys. After that, we insert here K, and when we insert K here, so if you see here, it has the 5 keys, and 5 keys is not the permissible number. So therefore, this node is split into 2 parts against the mid value. Mid value is here F. So F will go up. F is here, and smaller values, then F should be placed in the left hand side. So these values are placed in the left hand side, and greater value, then F should be placed in the right hand side. So we have placed here G and K. So in this way we can insert K. After that, we are inserting another keys like D, H, M and M. D, H and M. So if we talk about this D is smaller than F. So therefore, this D should be in the left hand side of the F. So we need to insert D here. Now H is greater than F, and sequence of H is here. So therefore, S should be placed now. Now M is further greater than F. So M should be placed here. So we can easily insert D, H and M. So we are observing here all the properties of the B tree are fully satisfied. Reason is that all the leaf nodes are at the same level. It has 2 children, and we have here 3 keys, 4 keys. So this is our here permissible number. So there is no harm in it. So we can easily insert D, H and M. After it, we insert J, and if we insert J here, then J is greater than F. So J should be inserted here. And now observe here, it has the total 5 keys. Permissible value is here 4. So this particular node will be split into 2 parts against the mid value. So therefore J will be go up. J is here and split into 2 parts. Smaller values from J, G and H should be placed in the left hand side of J, and greater value than J or K and M are placed in the right hand side of the this particular J. And now we have another values like E, S, I and R. So further here, if we observe E is smaller than F, so it should be placed in the left hand side of E. So we have placed E here. Now we have here S. S is greater than J, so S should be placed here. Now I greater than F, smaller than J, so therefore I should be placed here. Now last value is here R. R is further greater than J, so R should be placed here. So B people are further perform the insert operation without violating the B tree property. So further this particular case is being satisfied the property of the B tree. Now we want to insert X. Say here this is the X, and X is greater than J. So therefore it should be placed in the right hand side of J. So we are putting J here, we are putting X here, and further here we have here 5 keys. Possible number is here 4. So further this is not violated the property of the B tree. So it will be split into 2 parts against the value of R. R will be up and split into 2 parts, Km and Sx. Km and Sx. So further this particular case is being satisfied the property of the B tree. Now if we want to insert the C, C is C is smaller than F. So here further we have the total 5 keys, and the possible number is here 4. So it is further split into 2 parts. So C will be go up, and we can split into 2 nodes, D, E and A, B, like this. And now we want to insert another keys just like L, N, T and U. L, initial value is L, so L is greater than J, smaller than L, R, L is placed here. Then N, N is this is here our N is further greater than J, smaller than L, smaller than R, so N is placed here. Now T is greater than R, placed here. Now U is greater than R, placed here. So if we observe here, this particular case is being satisfied all the property of the B tree. So this is further B tree, so there is no harm in it. Now we want to insert the P here. How we can perform the insert operation now? P is greater than J, smaller than R. P is here. Now it has total 5 keys. So it has 5 keys. So therefore this node is split into 2 parts against the mid value. Mid value is M. M should go up. M is go up. KL, NP, like this. And now see here very interesting case. After splitting further at this level we have the 5 keys, and our condition, our properties here, maximum permissible value is 4. So therefore this node is also split into 2 parts. So this is the reason to explain various insert operations so that you people can easily understand how nodes are split. So first split is here and second split is here. Now J should be up, left hand side, right hand side, like this. So this is our case. So in this way we people are able to perform the insert operation. So I am sure that you people can perform any number of insert operations. So basically insert operations may lead to split condition, and split is performed whenever our condition is violated of the maximum number of keys. This is the basic idea to insert the any key into the B tree. Now we also try to explain the delete operation. So this is our here B tree that we have created now, and if we want to delete E here from this case, so delete E here, E is here. If you see, if we delete E, after deleting E, so we have here only one key, and minimum number of keys should be 2 because order of tree is here 5. The minimum number of keys should be 2, and it has only one key now. So we have to borrow the key from its siblings. So further AB, here we have the 2 keys. So borrow is not possible from here. Now C, right hand side, G, HI. So here we have the 3 keys. One borrow is possible. So we can take the borrow key from this particular node, and how we can take the borrow key from this particular node? G will go upward, F will come down, like this. So in this case, G will go upward and F will come down. So in this way we people can perform the delete operation, and from the borrow from its neighboring nodes we can execute the delete condition. So this is the proper explanation how we can perform the insert operation or delete operation. So this is the idea to explain the concept of the P3. Thanking you.